All right, our next lesson is about cross-sectionals. What are cross-sectionals? Well, it's when you have area between two curves and then you have some sort of two-dimensional shape that comes up and they're sort of like slices, and you have so many of these little tiny slices that they end up creating a larger three-dimensional shape. This is the ones we made last year in calculus. We were going to make them this year, but we may or may not have time to do that. They all use the function square root of x. If I turn this way, you can see how we have the square root function coming up like that. But you notice that it is a three-dimensional looking shape like this because of the slices that it's made up of. So the first one, the cross-sectionals, are isosceles triangles. The second one here is made up of squares. And the third one is made up of semicircles. So you can see that when we take a three-dimensional shape of volume, we can slice it up into different shapes and then find the volume when we accumulate all those areas together. So again, we're using integration because it's an accumulation function, and here is another way to look at it. Here I have cross-sectionals that are equilateral triangles. Here I have cross-sectionals that are semicircles. And on the other side I have a cross-sectional that is made up of squares. And here I have a cross-sectional that's made up of isosceles right triangles. And you can see there's some notation on the page about f of x minus g of x. That area of the curve, the area between the curve, is actually the length of my square, right? If I were to turn this paper sideways, you can see the length of the square, which is also the height of the square, is f of x minus g of x. Same thing here. My isosceles triangle has a length and a height of f of x minus g of x, because I'm taking the distance between the top curve and I'm subtracting off the distance from the bottom curve, and that is the length of my triangle. And the same thing with the semicircle. The distance of the semicircle, the radius of it, is the distance from the top curve to the bottom curve. So that is a really fast explanation of cross-sectionals, which is our next lesson.